Now this time what we want to do is graph functions of the type of y, the function, square root of the function here. So what we've got to do is, again, we've got certain rules we need to follow. We've got certain situations that will always exist. Now, you have graphed the square root of functions before. So what you've got to consider, though, when we do this, is it the positive or the negative? Now, we know if we looked at y squared is equal to x, then that would be a parabola on its side. Now, you've done that before in the 2-unit course, so you know that's going to be the case. So what we've got to consider is, okay, what about if we're taking the posit y is equal to the square root of x, but also if we take the square root of both sides, it could be the negative square root of x. So it depends on what we're given. So we've got the positive square root there of x. Now, things you need to consider again. Now, again, where is cutting the y equals x there? So the idea is that because we go through at 1, 1, the function of x, because it's the function of x there is that function, then we're taking the square root of that. We compare it to the line y is equal to x and then take the square root of it. Now this time, if we remember, if we take the square root of a fraction, it becomes larger than its original number. So if we square root of a quarter, say, so halfway with here, would become a half. So you can see, like, there's a quarter. Square root of a quarter is a half, because a half times a half is a quarter. So that's why it goes, and it's going to be above the axis. But again, the square root of 1 is 1. So that's why we've got the two curves meeting at that point. So that's why between 0, the y values of 0 to 1, when we take the square root of that, it's going to be above the curve. But after y values being equal to 1, so that's the key here, then the square root of the function is going to be less than the function. And the same thing is going to happen if we're taking the square root of the negative square root there. The key values are going to be at 1, so at minus 1. So when it's going to happen, and my graph is well and truly out there, that it's going to be going through at 1. Where is it going through at 1? And the curve's going to be less than that. So yeah, if I drew it a little bit better, it would be going through there. So we'd have to consider that we've got y is equal to minus x in this case, and the curve would be above it, and after it, it's going to be closer to the x-axis, because it's not going to be as large in absolute terms. So the rules we're going to need to follow. First thing, that the square root of the function is only defined for the function being greater than or equal to 0. So it's only going to be defined there. So when we look back at this one, it's not defined for these values here. We can't take the square root of those. So the function of x has to be above the x-axis for us to play around with that. If it's not, then we can't do it. The square root of the function is greater than 0 at all times. So, and that's a positive square root. It's going to be negative square root. Well, obviously it's going to change. Square root of function is less than the function when the function is greater than 1. They're equal when the function is equal to 1, and the square root of the function is greater than the function between 0 and 1 when it's a fraction. And then you can get this derivative as well. So critical points obviously would be the first derivative is undefined as well with this case. So you can get a first derivative of the graph as well, but realize that there's going to be critical points where the function's undefined. So let's have a look how we use the graph to do this. So we've got the graph in a few different ways. X minus 1 and x minus 2. Again, this is where we should draw up the graph every time. So x minus 1, x minus 2 is our nice parabola. If we're going to get the positive square root, well, what's it going to look like? Well, again, our function's going to go through 1 there and 1 there. So we found, well, where does the function equal 1? That's where our square root of our function will go through as well. It goes through at 2 here, so that's why it's going through at root 2 there. And between 1 and 2, the function of x is negative, so it's undefined. So it only comes up to that point, and only comes up to that point there. And notice that we're getting to a tangent that is vertical there. So because you're getting to the point where, well, that point there, if you took the derivative, is starting to get undefined. That was that last point that we're talking about. It's starting to get a derivative at the at the vertex, it's undefined, so it's going to have a vertical tangent. So the second one we're looking at, well, that's that one again there in a bigger graph. If it's a negative, well, it's going to be the reverse. It's going to be the opposite of that. It's going to be the curve with just the negative values of what the positive ones were. So we had it up there before. So it's going to be the negative square root. It's going to be underneath. You've seen ones like it's like when you take the positive and negative square roots when you're dealing with a circle and get the semicircles on the top and bottom there. So it's a similar idea. And here's the one where we've got the y squared equal to the function of x. So notice it's both curves, even though I've got the same colors, because when I did these originally, the function, my graphing program wouldn't do it. It does it now, so I should update it, but you get the idea that both functions there are now, both the positive square root and the negative square root are what we are taking. Notice though now, it's not a function anymore. So when we do that, we don't get a function. So we can have to consider that as well if that's going to be important to our question. So consider the function of cos of x. So there's our cos of x in the blue. And can we get the square root of the function? Well, have a look in the red. Where it goes through 1, it stays at 1. And notice, remember, for cos of x, all the values are between 0 and 1. So it plays a part. Notice now, because we're taking the square root, all the values are above the curve. When we did the square before, all the values were on this side because the square of a fraction is smaller, but the square root of a fraction is larger than the original fraction itself. So that's why we're looking there. Notice it's undefined for our negative values because we can't take the square root of a negative function value there. And notice we're coming down to vertical tangents. So that's important to be able to draw those at those points there. So they're coming down and they're going to be vertical at that point. So what does the y squared look like? Basically the same thing reflected in the x-axis. So if you can draw the square root of x, you can draw the negative square root of x, and y squared is equal to the function. It comes up in that manner where it's both of them put together. So x squared minus 1, there's our x squared minus 1 there. Again, I like drawing the line y is equal to 1 there. So again, I'm getting the values that are between 0 and 1, and I can see, well, that's where the curves are going to intersect, and that's then I'm able to get my values above the curve there and below the curve here on both sides. Because again, it's going to be if that's an even function, the square root would be an even function as well, and we can see that our values come down and are vertical there, but we've got to make sure we have this looking nice in the curve there and below there. So that's why I like drawing up y is equal to 1. Just helps me to get that part right. And what does y squared over the function equal to the function of x look like? Well, it's both of them together. Okay, and we start to get, and something we'll look at in our next topic, a nice little hyperbola happening. So we'll see that equation happening a bit there. But that's what it's just going to be reflected. There's the 1. If you want to draw up minus 1, you can get that nice reflection happening and get that symmetry happening there. For cos of x, well, we can see what's going to happen here. For cos of x is the same as cos of x, except we've got an amplitude of 4 this time, which means our function is going to go through 2, so that's important. And we draw up when y is equal to 1, so we're able to make sure our curve will meet, our two curves meet on y is equal to 1. And our curves greater than our new functions greater than the old function. So the square root function is greater between 0 and 1, and less than the function when the y values are greater than 1. So, and it's undefined there. And what does y squared look like? Well, again, reflection there. So what we had there, these nice look almost elliptical there happening. It could work out to be an ellipse, but not in this case because it's going to be a cos function. So again, 3x minus x cubed over 4. There's a cubic that's happening there, like we had in the last video, and we've got our values where it's meeting. Again, draw up y is equal to 1, so we're able to see what our function is going to look like. Our curves above there, it's going to be coming up and turning there. Again, the turning points would stay in line, depending on what our values are. It looks like 2 there. We're not too worried about that. We're more worried about, are we getting the going through 1, where y is equal to 1, we're getting it, and our curves are looking like they're below the curve there and above the original function there. And again, you can actually get a better graph just drawing it freehand. I think then you can show that gap a bit more, and you can see it coming down as a vertical tangent a lot better than what I can with the graphing program. And there's our graph when it's y squared is equal to the function. So again, 4 sine of x, like we have 4 cos of x before, where it's positive, it's defined, where it's negative, it's undefined. And you can see the curve above and below, and then above again. So going, meaning where y is equal to 1. Again, I implore you, urge you, to get that y is equal to 1 drawn there, just so it looks nice and it comes out well. And so you're able to get your graph looking like that. And then y squared is equal to the function of x. It'll be the same with both those there, so you're getting that reflection happening. And then this one, graph of 1 minus x squared and 1 over 1 plus x squared. So if we drew that up, we can see that it's less than minus 1. It's undefined because it's going to be negative values and greater than 1. It's undefined, so the square root, and then it goes up to 1, turns at 1, and so our graph's going to be just totally above it there, coming down vertical tangents at minus 1 and 1. So there's your rules for, and some examples on taking the square root. Again, if you can follow some nice rules there, look at where the curves between 0 and 1 and then greater than 1, you're able to draw this up without too many hassles, I feel. So have a look through again if you're not sure about the work, and we'll be attacking these problems next week and seeing if we can draw them up and put our rules into place.